Let's use IUPAC nomenclature to name a few compounds. The first compound that we have is CH3CH2Cl. Alright. Now the first step is to count the number of carbon atoms in the compound. And what is that? Right. This compound contains 2 carbon atoms. So it will be named as ith. Now let's attach the remaining atoms to these carbon atoms. Since the compound is a saturated compound, suffix "ane" will be added to ith. The compound also contains 1 chlorine atom, as you can see. So prefix chloro will come before ethane and the name of the compound becomes chloroethane. Now let's take another example. CH3, CH, CH, CH2, CH2, CH3. As you can see, this compound contains 6 carbon atoms. So it will be named as hex. Now let's attach the remaining atoms to these carbon atoms. On doing that, you will observe that carbons 2 and 3 still have one valency unsatisfied. So there will be a double bond between these atoms and suffix "ene" will be added. Now since the double bond is present at the second position, the name of the compound is 2-hexene. Let's take one final example now. CH3, CH2, CH2, COOH. What is the number of carbon atoms in this compound? Right, it's 4. Therefore, the base name of the compound will be bute. Now, since this compound is also a saturated compound, suffix "ane" will be added to bute. As you can see, this compound contains COOH as the functional group. So, suffix "oic acid" will also be added. Now there is a special rule in this case. If the last letter of a hydrocarbon is E, as in this case, then E is deleted when the suffix for the functional group is added. So what is the name of the compound? The name of the compound is butanoic acid.
A bromine molecule, you very well know, is non-polar in nature. So there is no charge separation in it. However, when this bromine molecule approaches an ethene molecule, it becomes polarized. And what do you mean by that? This means a separation of charge takes place in the bromine molecule. Let us try to understand why this happens. This happens because the pi bond in ethene repels the electron pair forming bromine-bromine bond. There you can see it. Now this results into an induced dipole. The positively charged end lies in closer to the carbon-carbon double bond. Now because of this, it orients itself in such a way so as to get attached to the double bonded carbon atom. Alright? And finally, this results in the formation of a positively charged carbon atom. That is a carbocation. In this manner, a dibromoethane molecule is formed. Can you tell me which is the simplest alkyne? That's right, it's ethyne. Both the carbon atoms present in ethyne are sp hybridized. The sp hybrid orbital of one carbon atom axially overlaps with the similar orbital of another carbon atom, and it forms a carbon-to-carbon sigma bond. Now what happens with the remaining sp hybrid orbital? This sp hybrid orbital of each carbon atom overlaps axially with 1s orbital of hydrogen atom to form carbon to hydrogen sigma bonds. Now, each carbon atom has also 2 unhybridized p orbital, which are perpendicular to the plane containing the carbon to carbon sigma bond. Now, these p orbitals overlap sideways to form 2 pi bonds. Now this bond angle That is, the HCCH bond angle is 180 degree. And the carbon to carbon triple bond length is 120 picometers.